New ultrathin material created under extreme pressure. An international research team with members from Linköping University has discovered a new material with a thickness of a single layer of atoms. The properties of the material, beryllonitrene, are similar to those of graphene. It is created under extremely high pressure and consists of beryllium and nitrogen atoms. The results have been published in physical review letters. Diamonds are created under extremely high pressure, but once formed they are one of the hardest known materials in the world, and are fully stable when the high pressure is removed. This is a property we are seeking in our quest for new ultrathin and functional materials, says Igor Abrikosov, professor of theoretical physics in the Department of Physics, Chemistry and Biology at Linköping University, LU. Together with researchers from countries that include Germany, the Netherlands, France and the US, the LU researchers have discovered a new layered material with properties similar to those of a familiar supermaterial, graphene. The new material, beryllonitrene, is created under extremely high pressure and retains its properties outside the laboratory, something that is unusual for materials synthesized at high pressure, and a fundamental requirement for future applications. Ultrathin materials can have amazing properties with many conceivable applications. When seeking new materials, we can mainly use temperature and chemical composition to control the structure of the material. But recent developments in technology now allow us to create materials under extreme pressure. This opens for many new possibilities and exciting materials, says Igor Abrikosov. At the speed of light, as the name implies, beryllonitrene consists of beryllium and nitrogen atoms arranged in a two-dimensional structure. Each beryllium atom binds 4 nitrogen atoms and together they form an asymmetrical hexagonal pattern through which the electrons move. The electrons in a structure of this type move with speeds close to the speed of light, which is a requirement for future research in particle physics and quantum mechanics. Using materials such as graphene and beryllonitrene is an amazing addition to large particle accelerators. These materials will enable us to study the smallest constituents of matter and their fundamental properties, sitting at our office desks. We will eventually be able to study and simulate the properties of our universe and of alternate universes, says Igor Abrikosov. This vision, however, will require more research before it can be made reality. The hope for the immediate future is that beryllonitrene can be used in quantum applications such as extremely rapid calculations. Deeper understanding with visualization. Beryllonitrene forms the base of a completely new group of materials with huge possibilities. The discovery has been published in physical review letters, and is the result of a large international research collaboration in which scientists from Linköping University have carried out the theoretical work. Ingrid Hotz is a professor at the Department of Science and Technology at Linköping University. She has led the scientific visualization of the material and the creation process. According to her, visualization is vital to obtain essential information about the separation, connection, and bonding of atoms in a crystal, which are responsible for the physical properties of the material. Humans are very good at recognizing patterns in visual representations. Visualization is important to obtain a deeper understanding of the data and underlying physics of the material and the creation process. These measures support an objective comparison of changes in material characteristics under changing conditions, such as pressure, says Ingrid Hotz. The research has been financed by, among others, the Knut and Alice Wallenberg Foundation, the Swedish Government Strategic Research Area in Materials Science on Advanced Functional Materials at Linköping University, the Swedish E-Science Research Center, (SERC), the Swedish Research Council, and the FUNMAT II Competence Center in Materials Science. The article, High-Pressure Synthesis of Dirac Materials. Layered van der Waals Bonded Beryllium Nitride Polymorph Maxim Bykov, Timofey Fedotenko, Stella Cheriton, Dominique Laniel, Konstantin Glazarin, Michael Hanfland, Jesse S. Smith, Vitaly B. Prakopenko, Mohammed F. Mahmoud, Alexander F. Goncharov, Elena V. Ponomarova, Ferenc Tasnadi, Alexey I. Abrikosov, Talha bin Masoud, Ingrid Hotz, Alexander N. Rudenko, Mikhail I. Katsnelson, Natalia Dobrovinskaya, Leonid Dubrovinsky, Igor A. Abrikosov. Physical Review Letters 2021 doi. 10.1103, Phys Rev Let.126.175501. Footnote. Graphene is an ultrathin material that consists of a layer of carbon atoms arranged in symmetrical hexagonal structures. The material has many desirable properties such as high strength and high conductivity for both electrons and heat. The hunt for further two-dimensional materials has increased in intensity after the discovery of graphene.